Hello, I just bought a XANTREX XPH75-2D, and that's a dual 75 volt 2 amp supply, or you can make it a single 75 volt supply 4 amp, or 150 volt 2 amp supply. Pretty useful, but like everything I buy, it was broken when I got it. Now, for better or worse, power supplies have gotten a lot more complicated than they used to be, and in repairing anything, it's a little bit of luck and a little bit of knowledge, and with a little more knowledge you have a lot better luck. So I'm going to go through the steps of how I repaired this. If someone has one of these, it might save them a little bit of time, and just the general idea of how you repair things. Most people don't know how to go about it, so I'm going to take a little time here to show you how this supply works. We come in with the AC filter, and this is something I've never seen before. The AC cord connects directly to this, and then after the filter they have the fuse and the switch. So if your filter shorts out, you don't have any protection. I don't know why they did this, but I've always found XANTREX supplies, I have a lot of them, and they're the best things made, in my opinion. So anyways, you start off with this, and you have your normal bridge rectifier, but instead of just charging the capacitor, you go through this FET and an inductor. It's basically a boost type circuit, and it's designed, it's a power factor control, and it's this chip right here. And what it does is it makes the power supply load look like a pure resistance, or as much a resistance as it can, instead of just a big peak at the peaks of each power cycle. That's a very poor power factor. A lot of CE regulations requiring power supplies over a certain size to have this feature. But what that means is, for this thing to even start to work, this amount of electronics has to work, which powers the capacitor. That capacitor involves the inverter that powers this transformer, and a tap off this goes into this little power supply here that powers the circuit again. So you have what is, the chip will have an initial start power that's run right off the power line. It's enough to charge a capacitor and get the chip working, but it has to sustain itself. Now this one, when I got it, you would turn it on, and a couple little LEDs would flash for just a moment every second, which means the thing was trying to operate, but it wouldn't sustain itself. So, like I say, you have to have this inverter, and then this inverter operates the two independent power supplies. So let's go through some of the steps of doing this. I like to make a little diagram of the layout of the board, and what this does is just the whole fact of having to write something down sort of ferments it in your mind. And so here you have the L4981 chip. If you see a chip you don't recognize, pull the data sheet on it. It'll tell you a lot of important information that will give you an idea of how to work. So this is the flow going this way. And like I say, you go into the bridge rectifier, your power factor control, you charge the capacitor, and then you have this PWM switcher, and that operates these two power supplies coming out here. There's two opto isolators here, and initially I thought these were to control the voltage, so if the main supply of either one got too high, this would turn down the inverter. But it turns out it's just a protect device. If the power voltage ever goes too high, it just shuts everything down. And that's important to remember. Now over here, right next to the 7815, there's an SCR, and if this supply here, D56 and D5 coming from this transformer. If the voltage gets too high in it, it just shuts this down, and once it puts a load on it, of course, it stops the whole thing from running. So what you have is a looping system that protects itself. But you know, a lot of times in electronics you like to force things because that's the only way you can test them. You know, you can't test something that doesn't have any voltage on it. I use one of these dim bulb testers. It's just a light bulb or two in series with the power line, and for a lot of things this is really nice. The bulb will glow very dim. The resistance of a bulb changes like 10 to 1, so a lot of times you'll allow it to, if you have a shorted out amplifier or power supply, it allows you to go through, make some voltage measurements without really burning up everything. You can burn up some stuff, but it'll be minor. You'll have time to you know, turn off the power. Now with power factor control, these don't work too well because as the voltage drops, it'll just ramp up the current. So this is a handy thing to have. So the next thing is you draw out a schematic of the input power. So we go through the filters. There's the switch, the fuse. We have one of these resistors that when it heats up, the resistance drops. This allows the capacitor to charge without a lot of inrush current. So here's your little boost converter. You have a diode, you have an inductor, and you have your FET switching, and this is the blue capacitor over here. The L4981 controls this out of pin 20. 1 is power ground, 10 is power ground, and 10 and 1 are both ground signal, and the power comes in to run this thing on pin 19. So here you have your transformer winding I was telling you about. It normally boosts up from this supply here, coming and charging this capacitor through these two 33K resistors, and across this input here there's that SCR. I don't show it. And then these two opto isolators power the inhibit. So if the voltage gets too high, it does a shutdown. But this allows you to look at what happens. When I initially got this, I put it on the dim bulb tester, and I fed in 16 volts here, just to force the thing to keep running to see if the switcher was working. And that appeared to work. Now, on each of the power supplies, there's power for the control electronics. Draw this out. These are the pins on the front panel that connect. So it's just a plus minus 15 volt supply and a 5 volt supply for running displays and everything else. Pretty simple. Now this is where things get complicated. If you look at the power supply sections, you know, you have a diode, you got a FET, you got an inductor, and you got a capacitor. And well, you know, that's a simple buck converter, right? Well, no. I've actually never seen one of these before in a supply, but the problem I was having with this is that this thing was going into automatic shutdown. And let me show you what the signal was on the opto isolator. I don't know how well you can see this, but this is the power that's going on the transformer. So anyways, the switcher starts working, and then this opto detects a high voltage and it shuts it down. This is when we finally run out of every little bit of power that was powering the opto. But it would just keep doing this, so every second it would burst, turn on. So I had the thing connected up to my dim bulb tester, and what I did was I shorted out this little opto-isolator. It's actually the higher one. This far supply is the one that was bad. So I shorted out the diode here. You know, it's only a volt on at maximum, so that wouldn't have done anything. And I thought what would happen is, you know, I'd be able to test if you ran the thing out of inhibit, would it power up something? Now this is kind of like a destructive test. You know, you can get damage, but generally you can go in there and tap it and you can see like, ooh, hey, it starts working. You know, that's a clue. So I did that, and immediately the displays all started working, and then smoke cards started coming out of the filter capacitor, the big black one on the supply, and you know, I shut it down very quick, but the cap did explode. Good thing I was wearing glasses. And when I turned the thing off, of course I found this capacitor shorted, and then these two resistors, the 220 ohm, they're quarter-watt resistors, they were both open, which really shocked me because, you know, quarter-watt resistors usually, I've had those things turn red for a couple minutes and the resistance doesn't change more than 2%. And these things failed immediately. They failed so fast, they protected the opto-isolator diode. I mean, that was kind of amazing. So I reconstructed this. These diodes here also failed. So I put a couple Xeners in series to make about 80 volts. That seemed about appropriate. You know, the capacitor is 100 volts, so the output was 75, maximum was 100, so 80 was close enough. If it ever shuts down and when I get close to 75 volts, I'll change that. But anyway, I still tried forcing this thing, and this supply just always wanted to go high. And this is crazy because you got two inductors, you got a diode, you got a capacitor, and the RRF 250. So there's a capacitor on each side of this. So you might be able to switch this a little bit, but basically they were running this in the linear region. And this actually happened to be like it ran from magnetic core saturation. So the inductor is basically a high impedance source, and as you start drawing current through it, it puts it into a nonlinear region. I don't know, never seen one before. And like I say, I went through checking values and everything else, and finally I hit upon this 1 ohm resistor here. It's 100 ohm into a fairly small transistor. How in the world can that shut down a power supply? But it did. And so my concern is that this type of resistor that they use seems to have a really high failure rate. So if you get one of these, this thing was made in England. I don't know, it's some European capacitor from somewhere. I don't know what it is. I've never seen resistors fail this easily. But yeah, I just had to replace that 100 ohm, and it's like buried. I had gone through and checked a lot of the resistors and diodes. You know, if you go across the FET and you can see the body diode and it's not like really shorted, chances are the FET's good. Same thing for inductors and diodes. So as it comes down, you didn't actually have to be really smart to fix this. You know, if you just had a $2 voltmeter from Harbor Freight and you just went around, checked every resistor, you could have gotten this one running. But sometimes they're a little more difficult, so that's where the knowledge helps out. So I don't know, hope you found this interesting. And now I have a nice supply. It only cost me 60 bucks. Thanks for watching.